Okay, our second example, again, we're going to simplify the RVE and then state all restrictions. Our second example is a multiplication problem. And so what we're going to do here is factor, as usual, as our first step. So we have a simple trinomial in the numerator that can be factored as a plus 5 and a minus 3. We have a common factor of 6 in the denominator, and I'd get a plus 5 in the brackets. I'm going to multiply that by, in the numerator here I have a difference of squares, so a minus 4 and a plus 4 would be the factored form. And in the denominator I have a simple trinomial again. And so I'd get a minus 4 and a minus 3. Alright, so now I need to state my restrictions again, and my restrictions are on the values of a that I cannot have. And so I can't have negative 5, positive 4, and positive 3. So in numerical order that would be negative 5, 3, and 4. And again, much like what I did in the first example, I'm going to ignore the second RVE and see if there's any factors in the numerator and denominator I can reduce. And in this case there is. I can reduce the a plus 5 with the a plus 5 here. And I'm going to do the same thing. I'm going to look at the second RVE and see if there's anything that I can simplify here as well. And you'll notice that I have an a minus 4 common in the numerator and denominator. So I'm going to cancel those away as well. And so this is a little bit more reduced. What the other part that you can look at is, because your operation is multiplication, this essentially means that all the numerator factors are being multiplied and all the denominator factors are being multiplied as well. So any factor that's common in the numerator and the denominator between the RVEs can also be reduced away. And this is only true because the operation you have here is multiplication. So the fun thing about multiplying and dividing RVEs is the majority of your factors end up canceling away, and you end up with a pretty nice expression like a plus 4 over 6 with the same restrictions that you had originally. And again, you'll notice in this case that all your factors that had variables were reduced away. And so the denominator only has a number part. However, the restrictions that you have here are based on the original problem. Okay, let's look at one more of these. And in this case, you have 2x minus y divided by negative 3xy squared divided by 2x minus y over 6x cubed y. And what you'll notice in this case is you have division between the two RVEs that we have here. And so the numerator and the denominator are already in factored form. So right away I can state my restrictions. And what you'll notice is in the denominator, x cannot equal 0 for the first one, and y cannot equal 0 for the first one as well. And you have similar restrictions in the second one. So my restrictions so far are that x and y cannot equal 0. Now at this point, because within the same RVE I can't reduce anything away, and be careful, you can't cancel out the x's and you can't cancel out the y's. The reason for that is because the numerator is written in factored form, but the factor looks like 2x minus y. That's the entire factor. Same thing on this side, the entire factor is 2x minus y. So all I can do at this point is rewrite the expression as a multiplication. And so I would get 2x minus y, and I'm going to put this in brackets just so that it's a little bit clearer that that entire thing is a factor. And then I have negative 3x y squared, and this one's obvious, negative 3 times x times y. Those are your three factors in the denominator. I'm going to change the operation to multiplication, which means I need to write the reciprocal of the second fraction. So I get 6x cubed y over 2x minus y. And my original restrictions are still there. X and y cannot equal 0. However, what you'll notice is this 2x minus y is a new denominator. Because it's a new denominator, that means it's got new restrictions. And so what I want to see is what value of this factor will give me a result of 0. So I'm going to do this one on the side because it's a little bit different. And so I do not want 2x minus y to equal 0. And so you'll notice that I have two variables in this case. So the only way to write this restriction is to have one variable depend on the other variable. Okay? You can't isolate just x and you can't just isolate y and get a number equal to x and a number equal to y, you're actually going to get dependence between the x and y values. So the easiest variable that I can isolate in this case is y, and I'll do that by taking it over to the other side or adding it to both sides, and I get 2x cannot equal y. So this is essentially my restriction. Y cannot equal 2x is another one of my restrictions. Okay, you'll notice that there's dependence between the x and the y. So my second restriction in this case is that y cannot equal 2 times x. So y cannot equal double the value of x. Okay, now that this is multiplication, we talked about already within the RVE there's nothing to cancel out. But because the operation is multiplication, this essentially means that I have 2x minus y multiplied with 6 multiplied with x multiplied with y in the numerator. And then in the denominator I have negative 3 multiplied with x multiplied with y and then multiplied with 2x minus y. So any factor that I have in the numerator and denominator I can actually cancel out. Okay? And right now I can actually reduce the 6 and the 3, the x and the x and the y and the y. However, I'm going to do that in the next step because sometimes it's easier to just see those terms in one fraction first before you reduce them away. So I have 6x cubed y over negative 3xy squared. And my restrictions are still the same. X and y cannot equal 0, y cannot equal 2x. And now I can try to reduce this away. And so 6 divided by negative 3 is negative 2. I have more x's in the numerator, so that'll leave me with 2 x's in the numerator still. I have more y's in the denominator, so that means I'll still have a y in the denominator. And my restrictions are still the same. Okay, so those restrictions follow through in each step. Okay, in our very last example, it's a bit of an application problem. It asks us to determine the area of the rectangle in simplest form and then to also state all restrictions. So right now, I just have the length and width as expressions, and I want to try to write the area of this rectangle. So remember that area is equal to length times width. And because I have both expressions, I'm going to write them out. I have x squared plus 2x plus 1 over x multiplied with x squared minus x over x squared minus 1. So my first step again is going to be to factor both the numerators and denominators. And so this denominator is fine the way it is. And the numerator factors to x plus 1 times x plus 1. It's a simple trinomial. I'm going to multiply that with, I'm going to factor the numerator. I have a common factor of x, and I'm left with x minus 1. In the denominator, that's a difference of squares, so I have x minus 1 and x plus 1. At this point, because everything is in factored form, I can state the restrictions. So x cannot equal, and so if we look at the values in the denominator, this denominator will only equal 0 if x is equal to 0, so that's one of my restrictions. And then in this denominator, I have 1 and negative 1 as my restrictions. Okay, so I have 3 restrictions. X cannot equal 0 or plus or minus 1. So that's just an easier way of writing plus a positive 1 and negative 1. You can write it as plus or minus 1. Okay, now it's a matter of reducing away. So because the operation is multiplication, any factor across in the numerator can cancel out with any factor across in the denominator. And so I have an x plus 1 in the numerator and an x plus 1 in the denominator. Those two will cancel out. I have an x minus 1 in the numerator and an x minus 1 in the denominator. Those will cancel out. And I have an x in the numerator and an x in the denominator, and those two will cancel out. So what this means is, to find the total area of this rectangle, I just need to look at x plus 1. Remember, your restrictions are still there. X cannot equal 0 or plus or minus 1. Okay, so for example, if I tell you x is equal to 7, it's much easier for me to just plug in 7 into the simplified area expression than it is for me to substitute it in all the different places in the length and width and then to find the area from there. So that's part of the reason why simplifying RVEs is kind of nice. When you get to an expression like this, it's very easy to determine the area. Now, it does ask us to state all the restrictions, and in terms of all restrictions, it's not limited to just these values. The other values of the restrictions are, remember that the length and the width represent side lengths. So we know that any value of x that'll give you a 0 or negative length are also restrictions in this case. So any value of x that results in a 0 or negative side length is also a restriction. And that's it.